All right, let's try this one more time with example 3. Same exact steps. Get 0 on one side. Now this time, this can be factored. I'm going to pretend for a second that we can't figure out how to factor it. If we're not sure how to factor it, what is our option for getting zeros? If you said quadratic formula, you are right on the ball. -5, negative, plus or minus the square root of -5 squared, plus or minus 4ac, minus 4ac. Got to get my formula right. And over 2a in the denominator. So what do we have here? 5 plus or minus the square root of 25 plus 16 times 6, 76? 96. All over 8. Is that right? I'm just checking myself real quick. Yes, I believe so. Let me know if I'm wrong. 5 plus or minus the square root of 121 over 8. Square root of 121 is 11. 5 plus 11 is 16 over 8. 5 minus 11 is negative 6 over 8. So our solution set here, we're going to check the regions between -3/4 and 2, which is what those fractions reduce to. Okay, so this does come out. We can factor it if we saw it right from the get-go, and we're able to break this down into 4x plus 3 and x minus 2. We could have worked with that, but I just wanted to put up the example of what do we do if we don't know how to factor it. Use the quadratic. All right, because we can't always test it from the non-factored line as well. Totally fine to do that. So I'm going to do that in this example just so that we can see it. All right, what's a nice number to the left of -3/4? Let's go with -1. Easy enough to use. We'll use 0. I'm going to use 3 here. Our equation to check is 4x squared minus 5x minus 6. Want to be greater than 0. And so if I plug in -1, -1 squared is 1 times 4 is 4. Minus 5 times -1 is plus 5 minus 6. That works out to be positive, and positive is greater than 0. So we like it. Let's plug in 0. 0 squared is 0 minus 0 minus 6. That's negative. That is not greater than 0. Don't like it. And let's plug in 3. 3 squared is 9. 9 times 4 is 36. Minus 15 minus 6. That's going to be a negative number right there. And so we do not like that one. No good on example 3. Going to the right of 2. And so I don't feel like I did that right. Let me check this real quick. 36 minus 15 minus 6 is not negative, is it? No, it is not. That is positive. I knew that didn't look right. We do like this region. Sorry about that. And so we can conclude that we have 2 regions for our answer. Negative infinity to -3/4, as well as 2 to infinity would be our solution set for this inequality. All right, give it a shot for yourself on problem 23. Here is the correct solution for 23. 3x squared minus 11x minus 20 is greater than or equal to 0. Let's try to factor this thing. Lots of options for 20, so we'll come back to that in a second. 3x and x. And we have to get to 11, thinking 4 and 5 right off the bat. $15 and 4. Yep. 3 times 5 is 15. 1 times 4 is 4. And we want to get negative 15 and positive 4. Greater than or equal to 0. All right, so negative 4/3 and positive 5 are our zeros. I'm going to use 0, I'll use 10, and I'm going to use, let's just use negative 10 here to plug these in. If I plug in negative 10 here, negative 10 times 3 is negative 30. Negative 30 plus 4 is a negative, so we'll have a negative. Negative 10 minus 5 is a negative. That's a positive. We like that region. If we use 0 here for x, plugging it in, 3 times 0 is 0, plus 4 is positive. 0 minus 5 is negative. That's no good. And lastly, if we plug in 10, 3 times 10 is 30, plus 4 is 34, positive. 10 minus 5 is 5. That's positive as well. And so we like that region. So we should have, this is our solution set, negative infinity, comma negative 4/3, as well as 5 comma infinity.